Okay, guys, just more of the same here. We are solving this time. Notice instead of a zero here or a number, we have y equals, and we're supposed to solve for x. Okay, so let's just remember how we did that in algebra. If we were going to solve this for x, we wanted to undo everything here and take everything using inverse operations over to the y. So we certainly would have divided by 3 first, right? And then the x is trapped under this square root, so we would have squared both sides. We'd have y squared over 9 equals 2x, and then we would have divided by 2 or multiplied by a half to get y squared over 18. That would have solved that for for x, right? Okay, same thing. I want you to see, instead of 3 square root of 2x, it's 3 cosine of 2x. We're supposed to solve that for x. We still divide by 3 first. The x is trapped in the cosine, just like it was trapped under the square root here. So we undid square root with a square. We're going to undo cosine with a cosine inverse. I'm going to take the cosine inverse of each side. And when I do that, the cosine inverse of the cosine, okay, I just get the 2x. Okay? So you're doing is that same type thing. We're trying to get that x out of there. And then the last thing would be to multiply by a half or divide by 2. So we have 1/2 cosine inverse of y over 3. And that's how we'll let it, just like we let this here, as y squared over 18. Okay, 1/2 cosine inverse of y over 3. Again, you might see that as 1/2 arc cosine. Sometimes people write it like that, of y over 3. Okay, either one. I tend towards the cosine inverse because that's what I see on the calculator. All right, that's the difference here. So we're still, I just want you to see the parallels between algebra and the trig. Okay, here we go. We have 2 arc sine equals pi. I want to get x all by itself, right? First thing, let's divide by 2. Okay? Now, to undo inverse sine, we're actually going to take the sine of both sides. Okay? In this chapter, we're doing, solving for a variable, and we're also solving equations that have the arc sine or the inverse sine or the inverse trig right in the equation. So you do the opposite. I'm going to take the sine of this side and the sine of that side. We're used to taking the inverse sine to get to x. Now I'm taking the sine. That gives me x equals the sine of pi over 2. Well, the sine of pi over 2, we know what that is. It's 1. So we actually get x equals 1. Sometimes I double check it, just like I would any equation. Kind of like x equals 1. That seems, is that all right? Put 1 in, arc sine of 1. And when we do arc sine of 1, we do get pi over 2. 2 times pi over 2 is pi. So that works out. Please check, because remember the inverse sine is a limited domain. The domain of that is negative pi over 2 to pi over 2. So we just want to make sure, negative 1 to 1. We want to make sure our answer is in the domain. Okay, let's try this one. So for example, in this one, we would be subtracting 4 pi from 1 pi. So that's negative 3 pi. Okay, so we subtract the 4 pi from pi. We get negative 3 pi. Divide by 4. Sorry, why am I not writing what's here? Okay, we have 4 tan inverse of x equals negative 3 pi. Divide by 4. I get tan inverse of x equals negative 3 pi over 4. Guys, this is where it gets a little tricky. You really have to keep in mind the domain and range. Maybe have them by you, the domain and range of all the inverse trig functions, okay? Inverse tan, the range of that. Remember, we limit the domain of tangent to negative pi over 2 to pi over 2 so that we have a one-to-one function and we can have inverses. So since the domain, we restricted the domain of tangent to negative pi over 2 to pi over 2, that means the range of inverse tan is negative pi over 2 to pi over 2. Well, that means the y values coming out of inverse tan can't be smaller than negative pi over 2. And negative 3/4 pi is smaller than negative 1/2 pi. So the answer to this is no solution. Okay, you can stop right there when you look at this. Okay, you know that that's out of the range, so that's not going to work out. Okay, let's try this one. Cosine inverse of x equals sine inverse, I think that's 1/2, maybe? I think, okay. For this type of problem, we're going to use a little u substitution, okay? Sine inverse of 1/2 means what angle, theta, do I take the sine of and get 1/2? In other words, opposite over hypotenuse would be 1/2. And I'm going to make the whole triangle here 1 squared plus x squared equals 2 squared. So 1 plus x squared equals 4. That means x squared equals 3. So I know this is the square root of 3. Since the inverse sine is of 1/2, we're obviously in the first quadrant because I'm positive. Okay, sine inverse is in the first and fourth quadrant. I'm not down in the fourth quadrant where I'm negative. Okay, so I want to know cosine inverse of x equals theta. Okay, this theta. So I'm taking the cosine of both sides. I want to know x equals the cosine of theta. Well, the cosine of this angle is square root of 3 over 2. All right, I like to show that method. I know you might have been able to work that out yourself, knowing that the sine inverse of 1/2, like that's a common angle. So we kind of already know that that angle is pi over 6. And then the cosine of pi over 6 is square root of 3 over 2. Could have worked it out that way as well. But sometimes we need this method, you know, when we're doing unfamiliar angles, like 5/13. Okay, so let's try that same idea here. Okay, I'm going to draw my angle theta. They use u. I know I said u substitution. I usually use theta. In the book, if you want to read through the book, they use u. I'm saying that the cosine of some angle is 5/13. So 5 squared plus this value squared equals 13 squared. We get y squared equals 169 minus 25. And we get that y is 12. Okay, so I have tan inverse of x equals theta. The theta I just drew here. Okay, this is saying what angle do I take the cosine of and get 5/13? Well, it's drawn right here. I'm going to take the tangent of each side. So x is the tangent of theta. So in my case, the tangent would be 12/5. Okay, so very similar type problems with the u substitution or theta substitution. Yes. Okay. Oh my, here we will definitely want to get the x's on opposite sides here so that we have arc sine x equals arc cosine x plus pi over 6. So I just have one trig function that I have to kind of undo. Okay. I'm going to take the sine of each side. All right. If I take the sine of this side, sine of arc sine, that'll just give me my x. And then I have the sine of, sorry, I'm going to write inverse cos. like to write. It's shorter. Inverse cosine. I have the sine of the inverse cosine of x plus pi over 6. Okay, now that's a sum, right? Sine of a sum. Let's go to our formula sheet and see what the sine of a sum is. The sine of a sum, we take the sine of the first angle times the cosine of the second angle plus the cosine of the first angle times the sine of the second angle, right? That's our rule. So, sine of the cosine inverse, that I'm going to have to draw a little triangle for, I think. Cosine of pi over 6, though, I know what that is. Oh, the cosine of the cosine inverse of x, that undoes each other. So I just have x, and then the sine of pi over 6 is a half. Okay, so I have x equals the sine of the inverse cosine of x times the square root of 3 over 2. I have to figure this part out, right? This is the only thing left that really is kind of annoying. So let's go over here to the side. The inverse cosine of x means what angle's theta gives me a cosine of x. Well, the adjacent side would have to be x and the hypotenuse would have to be 1. So what would this thing be? Well, x squared plus y squared would have to equal 1. Y squared would be 1 minus x squared. So it looks like y would be the square root of 1 minus x squared. Okay, good. That's what I'll write then. The square root of 1 minus x squared. I want the sine of this angle, right? Cosine inverse of x is this angle theta. The sine of that is opposite over hypotenuse. So I have the square root of 1 minus x squared. Okay, opposite over hypotenuse over 1 times square root of 3 over 2 plus, what, x over 2? Let's multiply everything. Oh no, I'm just going to subtract, I think, a half x from this x. That gives me a half x equals square root of 3 times square root of 1 minus x squared over 2. I can multiply everything by 2, getting rid of the 2's then. Square both sides to get rid of the square roots. Distribute my 3 through. Looks like I have 4x squared equals 3. So x squared equals 3/4. So x is going to be plus or minus square root of 3 over 2. See if there's anything in the beginning that makes me, oh, well, I need to be positive because of the domain of arc cosine. Okay, so it's just square root of 3 over 2. That was a lot. Pause it, look back through it, and then let's try this one on our own. I'm going to have to erase a little bit, or maybe I'll go to another slide because I made a mess. Okay. Try to maybe pause my screen and look back through what I did. I know this triangle's a little much. Okay. This one actually isn't as bad. If you'll notice the difference here, I had 2 x's. Here I don't have an x. Right here, what's the tan inverse of square root of 3? Tangent of what is square root of 3? Pi over 3, right? The tangent of pi over 3 is square root of 3, so I know the angle. It's not an x. Subtract pi over 3 from 2 pi over 3, and you get pi over 3. Sine inverse, so I take the sine of both sides. X is the sine of pi over 3, which we know is square root of 3 over 2. That one wasn't nearly as bad, was it? We like that. If they're giving us the angle, we'll take it. Okay. See you in class. Good luck on the homework.